This is section 4.2, graphing linear equations. Our vocabulary for this section. First we have a linear equation is an equation whose graph is a line. Then the standard form of a linear equation is an equation of the form ax plus by equals c. So notice a linear equation has to have both x and y, and standard form means that they're both on the same side of the equation. And then lastly, a linear equation is a linear function if the graph of the equation is not a vertical line. So in other words, if we have a line that passes the vertical line test, then it is also a linear function. Okay, so the solution of an equation involves both variables. Remember I said a linear equation has both x and y. So the solution to that equation involves both an x and a y coordinate. So we have an example that says, is the ordered pair 1, negative 4 a solution of 3x minus y equals 7? So what we can do is plug it in and see if it's true. So remember, my ordered pair is xy, so I'm going to plug 1 in for x and negative 4 in for y. So 3 times 1 minus a negative 4 equals 7. Well, 3 times 1 is 3, minus a negative becomes plus 4, and 3 plus 4 is 7. So, since it's true, that means the ordered pair 1, negative 4 is a solution of that equation. So the graph of an equation is just the set of points in a coordinate plane that represent all of the solutions of an equation. So that last example we talked about, that point was just one solution to that equation. So we're going to talk about several methods for graphing equations, but the first one we're going to learn is making a table of values. So let's look at the equation negative 2x plus y equals negative 3. So first, to make our life easier, to make our table of values, we're going to take this equation, which is actually in standard form, and we're going to solve for y. So just like we did with literal equations, because that's a negative 2x, I'm going to add 2x to both sides. And now I'm left with y equals positive 2x minus 3. Or you could write negative 3 plus 2x, either way. So now to make our table of values, we're going to plug in the x values and solve for y. The tricky part about making a table of values is usually choosing the x values. If it's a standard equation like this, these are a great set of points to choose. Negative 2, negative 1, 0, 1, 2. But the great thing about making a table of values is if you pick points that don't really give you enough points to work with, you can always just pick some more points. So let's just go ahead and work with the ones we have. Negative 2 times 2 is negative 4, minus 3 is going to be negative 7. Negative 1 times 2 is negative 2, negative 2 minus 3 is negative 5. 0 times 2 is just 0, 0 minus 3 is negative 3. 1 times 2 is 2, 2 minus 3 is negative 1, and 2 times 2 is 4, minus 3 is positive 1. So now that I have my table of values, in order to graph the equation, I'm just going to plot the points and connect the dots. So first at negative 2, 7, down here, this first one, then negative 1, negative 5, then 0, negative 3, 1, negative 1, and 2, positive 1. And with a nice straight edge or ruler, you can connect the dots, and the arrows on the end tell us that it keeps going on in both directions. Okay, so with graphing equations, we have two sort of special cases. We have horizontal and vertical lines, and their equations are always going to look a little bit different. So a horizontal line is always going to be of the form y equals b, where b is some constant. And vertical lines are always going to be of the form x equals a, where a is some constant. A horizontal line is always going to pass somewhere through the y-axis, so that's why it's always going to have a point 0, comma b wherever the constant is that it goes through. And then same thing with the vertical line, a comma 0 tells us where the vertical line crosses the x-axis. So to give you an example, first on the left, y equals b, remember, is our horizontal line. So let's look at the equation y equals 2. So for every value of x, no matter what value of x we pick, the value of y is 2. So the graph of the equation y equals 2 is a horizontal line 2 units above the x-axis. So when you see that, you know that you can just draw a straight horizontal line across at y equals 2, or if you forget, you can always plot points. So here they've just done -2, 2, 0, 2, and 3, 2, and then just connected the dots. Same sort of thing on the right. We have a vertical line. Remember, that's of the form x equals a, where a is some constant. So let's look at the example x equals -1. For every value of y, the value of x is -1. The graph of the equation x equals -1 is a vertical line 1 unit to the left of the y-axis. So if you see x equals -1, you can just draw a vertical line at -1, or you can pick points and connect the dots. So at -1, 2, -1, 0, -1, 1, -1, -1. The point is they all have an x value of -1, which tells us that it's a vertical line. So to help you remember that is this acronym called HOIVUX. We'll talk more later about what that middle thing stands for, but for now, this should help you remember that horizontal lines have a y equals equation and vertical lines have an x equals equation. And that's it for this section.